Moving from coverage to capability, we look at the details, the technical specifications that will bring this network to life. This is the engineering blueprint that ensures performance meets our promises. Our primary technical choice is the radio frequency band. For area name, we have selected band 20, which is 800 MHz. This is a strategic decision. Lower frequencies, like 800 MHz, travel farther and penetrate buildings more effectively than higher bands. This means we can achieve wide, reliable indoor coverage from a single site, exactly what our plan requires. Next, we've allocated 10 MHz of spectrum in a frequency division duplex, or FDD, configuration. This provides a balanced highway for data, with dedicated lanes for upload and download, ensuring smooth performance for activities like video calls. Combined with a 2x2 MIMO antenna system, this allows the tower to send and receive two simultaneous data streams, boosting capacity and user speeds without requiring more spectrum. Now, let's translate these specs into real-world capacity. Our design is built to serve the 200 residents comfortably. We model for peak concurrency, the busiest moment, where we expect between 50 to 80 active users simultaneously. For those users, the network is engineered to deliver strong, consistent speeds. Under normal loads, users can expect greater than 10 megabits per second for downloads. Even at the cell edge during a busy period, we target a minimum of 5 megabits per second, sufficient for standard definition video streaming. Voice calls will be carried over VoLTE LTE, Voice over LTE, which provides crystal clear HD audio and fast call setup. In summary, these specifications, the 800 MHz band, 10 MHz bandwidth, and 2x2 MIMO, are not arbitrary. They are the optimal technical recipe to deliver robust coverage and adequate capacity for areas scale, ensuring the network is both effective on day one and efficient for the long term. Following our technical blueprint, this part of VIDO translates that design into a clear view of required equipment and our budget allocation. This shows how we strategically distribute the total investment across the key components that make the network work. The capital investment, or CapEx, is thoughtfully divided across four main areas. The largest portion, roughly half of the total project cost, is allocated to active equipment. This is the core technology, the brains and communication hardware of the network itself. Approximately one-third of the budget is dedicated to passive infrastructure. This covers the physical foundation, the tower or mast, the antenna system, all cabling, and the protective equipment shelter. The remaining investment is split between the critical power and grounding systems, which ensure reliable, safe operation, and the installation and commissioning work, which includes both civil site preparation and expert technical labor to bring it all to life. Beyond the initial build, we must plan for ongoing operational costs, or OPEX. The single largest recurring expense, constituting about half of the annual OPEX, is the fiber backhaul lease, the essential, high-speed connection to the global internet. The other half of annual costs is distributed between site access fees, continuous power consumption, and proactive maintenance to ensure long-term reliability and performance. Moving from planning to action, we look at the project implementation timeline, a clear, phased roadmap to turn this plan into a live network for the community. The entire project, from final approval to launch, is structured into a 15-week, or roughly 4-month, schedule. This disciplined timeline ensures methodical execution while minimizing disruption. The journey is organized into 4 distinct phases. Phase 1, over the first month, is planning and mobilization. This is where we secure all necessary permits, finalize contracts, and place orders for our key equipment, laying all the administrative and logistical groundwork. Phase 2, spanning months 2 and 3, is the site build. This is the most visible stage. Our crews will prepare the location, construct the foundation, erect the tower and shelter, and run all critical power and fiber connections to the site. Phase 3, in the latter part of month 3, is installation and commissioning. Our technical team will mount the antennas and base station hardware, configure all the network software, and integrate the new site seamlessly with the national carrier's core network. Finally, Phase 4 is testing and launch. We will conduct rigorous drive testing across every street to validate coverage, perform final optimizations, and then formally cut the site over to live service for the community. Throughout this timeline, key milestones, like permit approval, tower erection, and network integration, serve as our critical checkpoints, ensuring we remain on track. In summary, this timeline reflects a coordinated, efficient, and transparent path to launch. It is designed to deliver a fully operational, high-quality LTE service to the residents of the area in a predictable and timely manner.
Mm-hmm.